specialized tools for different disciplines within design, engineering, and the enterprise. These tools may be proprietary tools built in-house or off-the-shelf tools. This has caused a segmentation over the time of the assets or IP, as well as there are unique systems or processes that may be in place within these disciplines. Design management tools may be different from the engineering bill of material management tools or the tools for managing enterprise processes like sourcing or scheduling or project management or manufacturing processes and activities may have completely different tools. Consequently, a lot of time is wasted in several iterations back and forth between the teams, exchanging data with each other, and several meetings are needed for different aspects of the product lifecycle to get to a common understanding. This results in a lot of inefficiencies in the overall product development lifecycle, stretching the cycle time, and potentially even delaying the product launch. An effective product development platform should merge the design disciplines and their specific IP into a single environment to allow for an efficient end-to-end development process. 3DExperience platform is a business platform for all. It allows you to manage your design disciplines with a range of CAD connectors with immersive design management capabilities within the CAD design environment. It goes further to eliminate the separation between the design and enterprise disciplines by integrating design with enterprise processes and disciplines like EBOM, enterprise change, supplier sourcing, IP security, material compliance, and program management, to name a few. Subsequently, all the stakeholders have direct involvement with all phases of the product development in real time. Real-time access to all IP related to the product, coupled with a single product development process across the enterprise, reduces the time to market. It increases the revenue and the margins due to reduction in the overall development cost. Here are some of the ENOVIA mid-market customers across the globe, across 3 different industries: transportation and mobility, aerospace and defense, and industrial equipment. These are customers who have either produced a case study with us, presented at a DS customer event, or have recently selected ENOVIA. This is only a sampling of some mid-market customers. And I don't expect you to read through all the customers in this chart. You will have access to this presentation. We will now look at how ENOVIA's data-driven design review capability helps improve design quality and reduce development time by enabling engineering teams to identify, track, and manage issues much sooner. We will also see how the ENOVIA solution provides one single environment for design and review, manages the design and review data in one place for informed and better decision-making to resolve issues sooner and reduce the development time. Let's look at the design review challenges in a file-based CAD environment. The number one issue is that the DMU used for review is never reflecting the latest CAD design. In a file-based CAD, the designers are checking out and locally modifying the data on their desktops. For design review meetings, designers are forced to check in the design data so that you can get the latest snapshot on the server for reviews. If any of the designers don't comply, you're already looking at the outdated design. Now, as soon as the design is checked in, it's already outdated because designers might check it out and start modifying. This results in focusing on issues which might not even be current product issues. The resolution actions need reconsideration because they might be on outdated design. It results in a lot of wasted time and effort. The enterprise users like service engineers, quality engineers, or supplier representatives might not have access to 3D, so they cannot participate in validating the design to capture issues. The design review information is captured in screenshots. The results of the review meetings is captured in screenshots and emailed to each other. So designers have to go back and forth between the CAD tool and another tool to understand the changes that need to be made, which can cause misunderstandings. When there are multiple variants and multiple CAD disciplines, which is very normal, it becomes a challenge to consolidate a DMU to capture any possible issues. All of these issues result in incorrect decisions and a lot of time that is consumed for design reviews, thereby taking the time away from the key objectives, which is design innovation. With ENOVIA, engineering and enterprise teams have lightweight access to the latest 3D product definition to review the design and discover errors as early as possible. While you're managing your file-based CAD files in the platform, the lightweight representations are accessible in real time within the DMU environment to the extended enterprise while the design is being developed. For example, manufacturing teams can access the work-in-progress 3D design and make suggestions to make a minor design update to a component that can help reduce the manufacturing cost of the component significantly. Similarly, sourcing or quality teams can participate in early validation and provide input to design teams to converge on the most optimum design much faster. So the design may be managed on the 3DExperience platform, as I mentioned earlier, or it could be managed in external CAD tools. If it's managed in external CAD tools, you can import the data in 3DExperience platform, leveraging a vast range of converters that support CATIA V5, SolidWorks, and even external CAD tools. And you can still benefit from this online collaborative DMU for the extended enterprise. A set of tools are provided to identify and communicate the issues, leveraging this real-time DMU. It is important to note that the review data that is created during the review process remains associated to the 3D design and is managed in the central single database. So it is always available to anyone from anywhere for making informed decisions to resolve the issues. With this real-time collaborative DMU, your cross-functional teams discover issues earlier and resolve them much quicker, bringing major reductions to the design times.
Here is a building manager that has taken a supplier plumbing fixtures and inserted it into the design of a stadium and found some interferences and wants to communicate these interferences to the supplier for corrective action and redesign. So here the building manager can create a data-driven design review simply by retrieving that interference that was found and using that to provide a real-time data visualization on top of the 3D model itself. And this can be captured and stored as data on top of the model and can be annotated by that manager so that he can share that directly with the supplier, who can then reference this and take action, all without sharing any files and just simply by looking at the data that's attached to the 3D model. So when the supplier provides a new version of the design, the building manager can take this geometry and use the review tool to overlay the two pieces of geometry and analyze and compare that so that he can see what's changed before he incorporates that into the assembly of the design. And the 3D compare shows that the pipe has been lowered, so the building manager can incorporate this new file as a new version of that plumbing fixture. He can then go and retrieve that interference check that he was done, and the data-driven nature of the interference check will look at that latest file and recheck the interference, and it will indeed show now that it's been solved.
You can take your DMU environment a step further to data-driven DMU without any assembly files, enabling quick and accurate design review in context of only required 3D data. While your file-based CAD is being managed in the platform, data-driven assembly nodes can be created containing real-time XCAD representations without any assembly files. This enables DMU review in context. In other words, as seen on this slide, over to the left, the fender, bumper, and other car components are being managed in file-based CAD tools like CATIA V5, Pro-E, NX, or SolidWorks. A DMU structure is being established with data-driven assemblies. These assembly nodes are data-driven, as in there are no assembly files, leveraging the data-driven design management capability of ENOVIA. The components within assemblies are pulled in from the XCAD design data in real time. And the positioning of these components is managed in the database and not in any assembly files. So when you draw a 3D filter on this DataDriven DMU, only the resulting components are pulled into the review session very quickly, enabling an accurate review session or accurate context for the review to identify issues in the area of your responsibility much faster. In this section, we'll look at how you can significantly improve engineering productivity with DataDriven CAD. Data-driven design approach improves productivity of design teams, enabling them to converge on the most innovative product design much faster, thereby enabling you to get to market more quickly and gain a competitive advantage. Let's look at the challenge any company has in front of them today. The complexity is increasing with the companies having to serve global markets. And it's very evident from the volume of data that needs to be managed. The number of parts that need to be managed are growing. The number of global design centers or global suppliers are continuously increasing. Now, these numbers up here on the screen may represent a large OEM, but it is no different for an OEM and suppliers in the mid-market. They're having to face the same challenge of increasing complexity. The result of this is that engineers are spending more and more time on non-value-added work like managing files, participating in several review and status meetings, several meetings with suppliers, finding the right data to work with is painfully long, etc., etc. Right? Some of the research actually indicates that over 30% of the time is spent on non-value-added activities, which is confirmed by more and more customers that we talk to. So let's see how the data-driven architecture of 3DExperience platform can help improve the productivity of engineering teams. Let's try to understand data-driven tools with some simple examples. File-based collaboration results in a lot of rework and wasted effort because as soon as the file is exchanged with someone, it is already outdated. Whereas in a data-driven environment, everyone is always looking at the latest data and making decisions based on real-time data. We have made this transition from file-based to data-driven in our personal lives in many ways, and there are several examples that I can take. For example, from the painful task of copying photos from every family member's camera or cell phone to one folder on a PC and always trying to keep it up to date, now we're using photo streaming on our smartphones on the cloud, where all the devices are automatically uploading the pictures on one single place, and all the family members are always looking at the latest pictures from anyone in the family. A very simple example of how we have transformed from file-based to a data-driven environment. Another example I like to talk about is Google Docs. Over to the left, you see 4 individuals working on collecting the expenses for a personal project using a spreadsheet. They email their inputs in the spreadsheet. They send the spreadsheets to each other back and forth over the email. Very soon, they're completely lost as to which one is the latest version of the spreadsheet and who made what changes. Now over to the right, they start using Google Documents, where all 4 of them access the document online. The same version they're able to access online and make changes on it concurrently, and they're able to see each other's changes instantly. They're always working with the latest version. Now, if you look at the engineering world, it is still stuck with CAD files. Engineers are managing files, checking in, checking out files locally on their desktops, dealing with the inefficiencies of managing the files for collaboration amongst teams or for design changes. If you have a file-based CAD system, working collaboratively is very challenging, as you are heavily reliant on check-in and check-out processes for file-based CAD data. Let's look at this example of design collaboration with file-based CAD. Here we have two designers, a simple example of two designers that want to work on the same assembly. First, they both need a copy of the files to be checked out locally on their desktop from the system or from the server. The designer 1 and 2 have checked out the entire assembly, let's say the engine assembly, to their local desktops. Designer 1 locks and makes an update to the connecting rod and save the new revision R2 locally on his desktop. In the meanwhile, designer 2 locks the piston within the assembly and saves the new revision locally on his desktops, which is revision 2. Now note that designer 2's piston update was in the context of older revision of the connecting rod and might not be compatible. So we already have three versions of the truth, one on the server, one on each of the designer's desktop. You can say that they can check in and check out their changes to be on the same page. Imagine that if there are more designers, let's say 15 to 20 designers typically that are there in a design team, all they'll be doing during their day is check out to be close to the latest data, but they'll still not be working with the latest data or the most current data. And what makes it even more worse is that designer 2 created a new revision of the assembly, the engine assembly, which is now pointing to the older revision of the connecting rod. The designers then check in the file to the system. What happens next? Over to the left, the designer's changes are in R1 of the assembly file. Now a time-consuming and a challenging task begins for the designer to reconcile the changes into the revision 2 that was checked in on the server by the other designer. And then he has to check in another set of files. The reality of this approach is that the designers often end up locking the entire assembly to avoid being stuck with this very difficult update process. And when this happens, when they start locking the assembly files, then no collaborative design can occur at all, and the productivity suffers. We'll now look at how the data-driven CAD can completely resolve the situation and help implement a real-time design collaboration environment, improving the productivity significantly. The transformation can be made when using data-driven design management that enables real-time design collaboration. Designers connect to the 3DExperience platform. They open the product assemblies. They don't check out. They just simply open the product assemblies directly from the database, which streams the data onto the CATIA v6 clients. They don't have to check out any files. Assembly does not have to be locked since it is managed in the database. So both the designers update the components within the assembly. Imagine Google Docs in action for CAD engineers. They're concurrently accessing the assembly, making changes to the component. When they want to collaborate, they simply stream the data to their workstations. They modify the components and save it back in the database directly. No check-in or check-out of files. The modifications are streamed back into the database. They're always working on the latest design connected to the 3DExperience platform from anywhere, anytime. Their open design sessions are automatically updated with each other's changes, and no reconciliation is needed. So this doesn't mean that there are no more files. What it means is designers do not have to manage files anymore. They don't have to waste time and effort in managing files. They spend their time only on one activity, which is design innovation. Data-driven design collaboration reduces the risk of errors from working on out-of-date information. It improves convergence on the optimal design solution by having engineers and designers to work in parallel on the product design. This data-driven CAD or design approach can provide improvements in productivity from 30% to 50%. Let's look at this example of two designers who can work concurrently within the same assembly. In this case, a supplier and an OEM designer are working on a serpentine belt assembly. The supplier is working on the idler pulley over to the left, changing the number of ribs to reinforce the design. The OEM over to the right is changing the location of the pulley assembly that includes the idler pulley that the supplier is changing. They both have data open directly from the database. The data is streamed from the 3DExperience database on their clients. The OEM is modifying the position of the assembly. And notice that the OEM has access to the entire engine, whereas supplier over to the left can only see what he's been authorized to access. So the security is taken into account, even though the supplier is directly connected to the OEM's 3DExperience instance. The supplier modifies the number of ribs for weight reduction. They'll now save the changes directly into the database. No check-in or check-out. By hitting Save button, their changes go directly into the database of 3DExperience platform. What will happen now is you'll see that their sessions will get refreshed automatically with each other's changes, eliminating the need for manual reconciliation efforts. They'll be visually indicated of the changes in their session. They'll be indicated what were the updates that the other designer made, and that their sessions will be refreshed automatically. This is the power of data-driven design management. Both the designers are always on the same page, making changes to the real-time design data, eliminating any rework that may occur because of outdated design. This tremendously improves the productivity. Here's an example of a customer using data-driven design. Class is a leading agricultural equipment manufacturer headquartered in Germany. They had an objective of design from anywhere across their design centers, and they realized it was only truly achievable with data-driven design enabled with CATIA and ENOVIA 3DExperience. Kai Wallish, who is the head of engineering methods at Class, says, "Product information is the same for everyone, which avoids errors that occur when the wrong design is used." So this has helped them improve their design accuracy and also reduce the engineering cycle time. Another challenge designers have to face on a daily basis is the long time taken to establish design context. Sometimes they have to go through this pain multiple times a day. And our customers tell us that designers have to sometimes wait up to an hour just to establish design session. Reason behind that is very simple. In a file-based CAD environment, when designers have to work with selective components from multiple subassemblies in an assembly, they're forced to download the entire CAD hierarchy because the positioning of the components is managed in assembly files. So all the assembly files have to be downloaded, and the components that are not needed are then hidden. Now this can take from minutes to hours depending on the size of the data. And this takes their time away from their main objective, which is design innovation. Whereas in 3DExperience platform, ENOVIA's data-driven solution, there are no assembly files. And the position of the assembly components are managed within the database. So only the desired parts resulting from a manual selection or from a search are retrieved in the right position in the client or in the design session. Designers get to a precise design context in a matter of seconds, as illustrated in this video. Here's an example of a designer navigating on this entire car product that contains thousands of parts very swiftly and very easily in this lightweight environment. It's a navigation environment where he is establishing his design context. He's now defining a 3D volume with this very intuitive tool around the area of his interest. And notice as he's drawing the volume, the parts contained in this volume are being highlighted in real time, or they're being included in this volume in real time, as well as over to the top left, the number of parts included in the volume are being calculated. This is only possible because all these components, their positioning is managed in the database and not in an assembly file. So in real time, these parts are being pulled into this graphical volume, and a design session is established just in the matter of seconds. The designer is enabled with this session, an accurate design session, in seconds to start working on his design activity. This has significant time savings for designers. We'll now go beyond the basics and look at the additional value that ENOVIA's data-driven design capability can provide to our customers. Another challenge we will look at is staggered launch of products globally. In today's age when companies have to serve consumers globally. Traditionally, the products are launched in a staggered fashion. They are designed and developed for one country and launched in that country, followed by others. The disadvantage of that is that the competition can copy features, differentiating features, and launch them in other geos ahead of you, hurting your overall market cap. It is becoming important for companies to achieve global simultaneous launch, which may take a little longer initially, but it pulls in the volume sales from across the globe upfront, improving the overall performance and the revenue generated by the product. Now, simultaneous launch can only be achieved if you have the capability to design all the variants of the product considering global market requirements. A Honda Accord in the US is a lot different from Honda Accord in India because of local consumer requirements and the environment in which it runs. So the engineering teams need to be able to design multiple variants of the product considering requirements of consumers in the countries the product is launched or targeted to be launched. This is what is achieved with design in a configured context capability. Let's take a look at it. Design in a configured context is a very compelling and differentiating capability delivered by the data-driven technology of CATIA and ENOVIA 3DExperience. Let's see how. Over to the left, you see the file-based CAD environment, where there is a single CAD structure per variant. So over the years, you end up collecting many CAD structures. So when a designer has to modify the design of a component, he obviously wants to make sure that it's reusable in the variants it is used. So the only way to do that in the file-based CAD environment is that he has to download the CAD structure for all the applicable variants and validate the design of his component individually in each one of those variants, which can be extremely time consuming. Our customers also tell us that for performing such design studies in file-based CAD environment, they create temporary CAD structures, which has no other value from an engineering perspective, but they're forced to create these CAD structures to get the right context. This can be very time consuming and still very error prone. Whereas over to the right, in the data-driven environment, there's a single modular 3D structure that contains all the variants. There are no assembly files. There are subsystems or assemblies that contains components in them, and these components are representing different variants of these systems. These components know their positions. The positioning of the components is managed in the database. They also know what options they're addressing. So you can partially load a session, or you can fully load a session by saying I want this particular option from this variant, this option from this variant, and this option from the third variant. Or you can even overload a session by saying I want this connecting rod and these two variants of the pistons to make sure that the changes on my connecting rod are are valid with both the variants of the engine so that my connecting rod is reusable. This is the design in a configured context capability that allows you to design considering all the variants that your design impacts, making sure that your design is reusable. It allows you to achieve the most modular design very, very fast. The higher the design reuse, the higher the part reuse. That lets you offer more variants at a lower cost. Let's look at this example. A housing designer for a mini projector product needs to design a housing that is common for all the projector variants. He needs to make sure it can accommodate both the variants of the battery. The high capacity battery is larger and the standard battery is smaller. Designer is able to create an overloaded design session on demand containing the housing and both the battery variants simply by selecting the configuration options within the design environment. He can now achieve the most optimum design for the housing accommodating both the batteries. This can be very challenging in the file-based environment, as I mentioned earlier. Now, data-driven design capability of CATIA and ENOVIA 3DExperience enables you to achieve the most modular design across all the variants, considering global requirements, helping you bring out variants much quicker and at lesser costs. 3D Configurator is a very innovative and differentiating capability launched in release 2015X on top of ENOVIA's data-driven design management. It helps engineering teams to validate configurations within the CATIA 3D environment, respecting all the feature and compatibility rules. Let's take a look at it. 3D Configurator provides a very intuitive experience with real-time 3D validation while respecting the compatibility rules between the features. On the left is the configuration dictionary established by the enterprise, directly accessible in the 3D environment. The user interface allows selection of only authorized options as per the configuration rules. Only the right-hand drive and the automatic transmission options are allowed for this model. The others are not even allowed to be selected. As the EX trim is chosen, the bumper with the fog lights is retrieved automatically. There's a powerful rules engine running in the background evaluating the rules very quickly, automatically selecting the options or disabling as per the rules. This provides a completely guided user experience, allowing selection of only valid options. As you can see, with EX trim, only alloy and chrome wheels can be selected. The 3D for the components is retrieved in real time. This is only possible because positioning of components is managed in the database and not in assembly files. The components know their positions and what options they are addressing thanks to ENOVIA's data-driven design. 3D Configurator enables engineering teams to accurately define configuration, addressing customer requirements with instant validation in 3D, thereby reducing the time to develop and market the variants.